Good morning, good afternoon, good evening, whenever and wherever you are, my friends. Alex here, getting ready to boot up the system. I've got a little bit of a different PC set up, so it might sound and look a little different, but let me know if anything goes sideways. We're going to be working on getting out the platformer that I have been promising everyone. So we're going to be starting from the very, very beginning with Super Toast World, and I want to show you guys how to build everything that you need to make a complete platforming game with overworld traversals, with level management, and in-depth game mechanics that are based on the Super Mario World and Kirby franchises. So let's get started. How's it going, everyone? Good morning. Remember, everyone will be editing the live stream videos from this tutorial, or wait, no, hold on. We'll be editing the YouTube tutorials off of this template or off of the video. So I'll be taking my time as I move through, covering everything you'll need to know. For a lot of people, this will be review, but I think it's really important. So let's get ready to do this. Yeah. All right. Let me just double check and let everybody know that all right. I know it's a double post, but let's go. All right. Let me get us flipped over to our main menu here, and we're going to get started. Let's make sure that I've got all of my Gdevelops open to the appropriate place, and I don't, so we're going to go ahead and close all those windows and relaunch them from the ground up. All right, we're almost done. Setup is almost complete, guys. Give me just a second. I had meant to preemptively do this, and I did, but alas. All right, we're going to need to open up this one. And we're going to need to open up this one. So I won't be spending too much time on things like the finite state machine and other spots because we've done this so many times on my channel, and I do want to make sure that those videos get seen. So if you haven't seen my finite state machines before, you should probably check those out on my YouTube here. So without further delay, let's jump into this work. Lovely little work of art. Okay, so I want to make sure that we all know what we should expect from this. Hey, Funk. I'm doing well, sir. How are you? Yeah, I'm looking forward to getting all of this done. I know that there's lots of people out there who are building platformers, so for me, this is a big one. Thanks for stopping in, bud. All right, let's get switched over here. So first thing I'm gonna do is get booted up into my art program, just because I know we might need to do a little bit of tweaking as we work on our project here. So we're gonna get switched over to the main screen, of course. Hey, what's going on, Clayton? Everyone does love a good platformer. So as I have said before, and I want to kind of show off kind of what we're doing here. So we're going to be building the more traditional Super Mario World format. For those that are interested, after this goes live and when the videos start rolling out, there'll be downloads for everything that you see here today. So by the time you're watching this outside of the live stream, it'll be in the download section below. So super cool. All for free, of course, of course. So I've got some, just a couple samples provided here. But I am working on the next step, which is the overworld sort of map movement that you might see in Super Mario World. And that is currently a work in progress, but when we get to that point in our development, we'll see it. I've got some extra assets kind of backed up over here, just in case you can see kind of what we're going to be working with. we're going to have some, build the Super Mario trigger, where once you hit this point, it's like a checkpoint in your game. We're going to have growing plant blocks that you can climb, as well as a variety of different block types for you to hit, and some coins and extra animations. So, like, pretty excited. Without any more spoilers, let's just get into it. So I think that when we start our a brand new project in Gdevelop by going to our project settings and creating a new project, I've already done so, as we can see here. But all you need to do is set it as optimized for pixel art, and we're just going to select the default desktop format. Another format that we could do if we knew this, if our scale of our game was right, is 320 by 1. I want to say 180. No, that's not right. 160? 180. 320 by 180? I want to say that that is correct. This is where I voice over and edit this later, but I just want to double validate that I did that on my other one. So let's take a peek real quick. Let's go into our properties. Before I tell you guys the wrong resolution, 320 by 180. I did do it. I did it right. Okay. So if you didn't do that at the start, you don't worry about it. We can go to your game settings, which is the project manager, which is this little thing up here in the top left. And then we're going to go down into properties and move down to our game resolution. We're going to change it to 320 by 180, which is a perfect scalable resolution for 180, 720, 4K, 2K, 4K. So we have lots going on there. We're going to make no changes to the... Actually, we're going to stretch the width, and I'll leave that as it is. All right. So we're going to start with the very, very beginning, a blank canvas with nothing present. So, I just very quickly, I'm going to move over some stuff on my desktop so I can manage it on my secondary screen while we're working here together. Hey, Abu. I miss you too, sir. I miss you too. We're going to move over some extra games that I have installed. Yeah, you saw it. Fallout 76. Fight me. Okay. So I have some things prepared, and if you see this in finality, when you download the files, it should look very, very similar to this. Maybe a little bit of different organization in total, but we have our game sprites and we have our tile set. And hey, there's never too much art that you could be doing, Babu. All right. So from the beginning here, we're going to start with preparing our game with the fundamental back end before we move forward with our art. And I know a lot of you are excited about getting your art uploaded. But we have a couple steps that we have to do first. So to do those steps, let me move this over a little bit so I don't lose track of chat. All right. So I already know that we're going to need to start with a couple of the basic things that I usually do when I get started, and that's starting with some organization. So I know that we're going to need a objects folder. This is the place where I'm going to hold our player, maybe grass, coins, any collectibles, that sort of stuff. We're going to create a new folder and make sure we don't make it a child of the objects. We're going to call this UI for, well, UI. And we're going to make sure that when we add our next, we're going to maybe add one for our camera. Oh, I did it as a child again. If you do that, you just drag it and drop it out. Okay. We're also going to make one for collisions. I know that we're going to have a lot of different types of collisions and elements that we're going to need to do. And then I think that we could do, we're going to make one for our tile set inside of collisions. So we're going to call this tile set. We're going to add another one in collisions called triggers. And we'll do one called blocks. And all of that will make sense here in a little bit. And then one more I want to make is the debug area. And in the debug right away, I want to create a text object. And we're going to call this text object debug text. We're going to leave it with an initial text just so we can see it. We'll leave it at 20 because it's fairly large. That may even be too large, but we'll see. We want to make sure it's not blurry, right? We're going to add a little bit of shadow depth to that. And we're going to plop it on our game scene. Now, because we just started a new project, we only, oops, wrong layer, Alex. We opened up, we need to open up the layer section and move off of the base layer. So one of the important things that happens in Gdevelop is that when you create anything and you put it in your canvas, which is more or less this little camera viewport. Well, technically the canvas is everything, but your viewport here, if you put it inside of your viewport and we start moving this camera around your canvas as we play your game, it'll move this text away. So what we want to do is create a new layer and call this UI, or for now we can call this debug layer because it's going to be a layer above the main layer. And we want to make sure that we move our debug text over into the debug layer. Now, if you clicked this button down here, it would automatically make anything you drag in here assigned to that layer. But we want to make sure that everything we drag in goes to the base layer. So, let's see here. If you're playing on a resolution of 300, so we have a couple of questions that are going on in chat, so let's deal with these. So Funk asks, he doesn't know if it's just him or not, but the native resolution of 320 by 180, the movement of the game doesn't feel clean. Could it be that Gdevelop doesn't have native sub-pixels movement? Now, there is a pixel perfect movement that we can use to fix that. It's an extension inside of the community. And also, if you got to pay attention to multiplying any sort of movement factor or anything that relies on a keyframe as time delta to make sure that things stay within the FPS. So to avoid tearing and things like that. So if we need to, we'll check that out. Your resolution could be the problem, as well as some of the settings in your game settings, which could end up being like the update the resolution or rounding. And this is round pixels when rendering, useful for pixel art games. Now, we can see here, if we disable smoothing for everything, we can avoid having some blurry things. So what's going on, Riley? Welcome. Okay, so back to this. So make sure that your debug text is assigned to your debug layer, and that'll get us to move forward. Once you get started here, the very next thing that we want to kind of do is just get our character rolling. And I think that the biggest and most difficult part of what we're about to do is the finite state machine. So we're going to start with that. We're going to start with the most complicated thing so that the rest of our game is easy to do. So before we get started, to get prepared for this, I want to create a global variable setting. And now we're going to prepare our game from the ground up with mobile. Oh my goodness, I had hiccups. Oh, hold on one second. I got more hiccups coming. I'm going to mute my mic. Okay, woo, I'm back. I survived the hiccup war. Okay, so the first thing I want to do is prepare our game for global controls. So we're going to have a menu in our game. We're going to need to save up some player data as well as custom key controls. And we're going to be building our game from the ground up with consideration for mobile and controller support. So we're going to do all that right now. So the first thing we want to do is to create a new variable, and we're going to create a couple of structure variables. So we just need to copy and paste this a couple of times. And we're going to name the first structure. We're going to go and call that settings. We're going to call the second one controls. Actually, we're going to call it key bindings. Key binding with an S. Key bindings. We need one for game data. We're going to be saving our player variable data, and it's not a multiplayer game, so we can use global variables. And we also need a default. Actually, this is just a Boolean, and we're going to call this startup. So the Boolean is going to start with the startup as false. And I like to do the, I want to say it's Hungarian. I can't remember the actual documentation style for double capitals. It's not camel case. Brip. All right, I'm just kind of in my own mind here. I'm kind of sick today, so also I apologize if you hear me sniffling. I've got a little bit of a stuffy nose. Yeah, my bad. So hopefully that doesn't weird you out. Inside of the structure, we're going to add, inside of settings, we're just going to do audio volume. Volume. We could just call it audio, I suppose, but audio volume probably makes the most sense. Yeah. And we're just going to leave that as a number value. We're going to set that automatically to 25. Just to turn down the audio of the game a little bit. Inside of game data, we know that we're going to need a time. Or we'll do a time, let's see, game data, map timer. We're going to call, and this will be, the map timer is going to be the, or actually we should call it level timer. And so the level timer is going to be a number. We can set it to 0 for now, or we can set it to like 299, and that'll be, or 250. Let's see. Actually, does anyone remember what the, from the chat, does anyone remember what the default is for Mario? It's 200 and something. 250, 260, I think, actually, is the default value. I could be wrong. And then it counts down from there. But we're going to use 260 for now. It may be longer than that. Maybe it's 300. It's been a minute since I played it. But we're going to start off with some sort of level timer. And this is how long you have until you run out of time. And we're going to build a system that minuses that every second. So once every second, we're going to go ahead and delete that and restart it. So the next thing that we're going to do is also add a character life value. So we're just going to type lives. We're going to make that a number as well. And for in good traditional value, we're going to go up to 3. And that's all we need now for a couple game values. Now I want to go into our structure for our key bindings. Press the plus symbol. And we're going to add another structure. We're going to call this controller. And we're going to add another one. And call this keyboard. And that needs to be a structure as well. We're going to start with our keyboard keys because we and some of our controller keys. So when you are developing a game in Gdevelop, you just a little tip here: you do not need to add the up, down, left, and right a input for controllers because they have them built in the extension. So all you need is like the jump key. So for now, we're just going to add the jump key, and it's going to be a string. And because we're going to be using a controller with A, B, X, and Y, we're going to set it to the A key, which is the bottom key in this case. Or if you're playing on an Xbox controller, it would be, PlayStation controller would be X. And we can actually diversify this down to the very controller, because if this controller is not an Xbox controller or a controller that has an A key, this won't work. So we can also make a jump alternative key, okay? And so all we have to do is go to keyboard jump and change this to jump alt. And the jump alt key will be X, just in case. And we'll have to program that in from the ground up. So now in keyboard, what we want to do is, and also actually we're going to add another one called controller count. Now, this is kind of important because what people don't know is that if you have a USB microphone, a USB headset in Gdevelop, then when you plug that USB in, it will register as a USB device. Now, in Gdevelop, if you are trying to use controller number 0, or the first controller in the array, it may register your headset first. So when we develop controller-based support in our games, we need to make sure that we include some sort of controller count or controller identifier. And actually, we're just going to go do controller ID instead of count. Hi, what's up, Ldev? Ldev asks, I'm undecided between Godot and Gdevelop. Which one should I choose? Well, I think this is a great question, actually, and thank you for asking. Seriously, thank you for asking. I want to say that the first thing we do, the Thor or Pirate Software on YouTube has a great breakdown of something that you should think about before you decide what engine you want. And for those that don't know, I'm going to go ahead and take the time to explain this. And it is called GEL. You are correct. So the first thing, and I like to draw, so get with me. So the first thing that you do is G, and then E, and then L. So the first thing you want to think about is your game, right? What game are you going to make? So if you I should ask you, Dev, do you know what game you want to make? What type of game you want to make? Do you have an idea of what it is that you're building? Because before anything else, this is really important that you decide these factors. Designing without some sort of structure is going to make your game engine development very, very difficult. Regardless of where you begin. So I'm curious what you have to say, what you're going to say about that, if you're still with us. A 2D mobile game. Well, that's pretty broad. Do you know what style of 2D mobile game you want to make? Is it a platformer? Is it a top-down shooter, like a twin stick game, where one moves you and the other one shoots? Or like, what style of mobile game do you want to build? So those are the first questions, right? So that falls underneath game. And you know that you want to do 2D. So we know that Gdevelop, the next decision you make is engine. So you want to make a mobile RPG. All right. So now that you know what game you want to make, right? So you want to make an RPG. If you wanted to make a platformer, let's do an RPG, whatever it is, you decide that first. And then you decide what engine you want to make that in. And so here you are in this question. You have to look at both engines and decide what they're built for and what they're good at. Now, Godot, or what some people call Godot, forgive my hiccup, is a very extensive and programming heavy engine. Now, I think it's very user friendly in terms of a programming language, but they have their own language. Okay. And so when you pick an engine, the next step is to figure out what the language is for that engine. What languages can you use in that engine? And Godot has GDScript, which is their basic language to functioning everything in that. And it's relatively straightforward, but it's still a programming language. And now Gdevelop is not an engine that has a programming language. Godot also does support C#, but they encourage you heavily to use GDScript because that's the language you use to interact with very easily with all of their components. And so it's been digested down to be the easier of the two and very forgiving compared to C. So I would very much recommend, though, but that's the language part, Riley. So we're not there yet. So he first needs to decide what engine he wants to use. Gdevelop does not have its own. It has a non-programming scripting format, a visual code style. But Gdevelop is from the ground up a 2D platformer, or not a 2D platformer. Goodness, a 2D game engine. I'm tired this morning, if you guys can't tell. And so, although Godot has lots of support for bigger projects, and is it more valuable to learn a skill inside of Godot versus Gdevelop? Probably, actually, in the long term of programming. But is Gdevelop a very robust and capable engine? It is. So right now we're kind of deciding for you what's more important, right? Is the convenience of having a engine that specializes in 2D but does not really have a language that you need to learn more valuable than taking the time to learn a programming language and dealing with that? So I would encourage you, before making that decision, watch this video. Watch today and see if this inspires you to use Gdevelop. If you watch this video and you say, no, I don't really want to use this engine, then there you go. It's pretty straightforward. So let's jump back into our programming here and finish up some of our controlling stuff. So we need up, okay, and these are strings now. So we need up, and this one will be W. Lowercase w for up. Now, actually, because this is going to be a platformer, I think we should actually use the arrow keys. So that would be up, like that. Defaultly, right? We're not going to be using our mouse for anything, so I think it makes the most sense. We're going to do down, and that should just be down, I believe. I don't think it's num key, or I don't think it's arrow down or anything like that in Gdevelop. I could be wrong here. We may have to fix this later. Left. Left. Oops. And it has to be, anything you do that's keyboard related starts with a capital when we're doing this. And then we're going to do one more, and it'll be right. And then we need another one, right? So we also need jump, which for now, jump key is going to be space. Or, wow, that should be called jump, Alex. That's jump, and the key is space. All right, so now we have a jump key and a movement key, and we have that for the controller and for the keyboard. And for now, that's what we're going to work on. Mobile we'll be adding in later, because it's a bit different to program in. So we'll be checking for those later. So we're going to hit apply, and now we have the base of our game. So before anything further, we need to make our game go, right? We have the base code to make it go, at least from a first rudimentary. We have the programming in place to do this. So let's actually do it. To do that, we need a player, and we need a few other objects in our game. So we're going to start with our tile set, and we're going to add a new object. We're going to do it from scratch, and we're going to create a tiled sprite. Now, the important part of a tiled sprite is a tiled sprite will repeat itself over and over without being stretched. If you use a regular sprite and you stretch something, it'll pull your image, right? It'll make it look real goofy. And so tiled sprite is perfect for the middle of platforms. So anything that is a middle, anything that stretches, like when you're building I'll just show you actually. So we're going to start it out. Everything in our game is 16 by 16, and we're going to choose the file, and we're going to start with the Super Toast World tile set. Now, in the middles in the future, you'll see all of the middles. Right now, I actually have them broken up into 2 spots. So anything that goes between a middle is not only the middle of a block in development. So if you're drawing your own art, we're going to go ahead and move back over to this game. When you're drawing art for tile sets, you generally draw in a 3 by 3 cube, which is 9 square cubes. And the middles are these. Anything that connects to the middle. These are all repeatable tiles. Now, an ending you wouldn't repeat, because that would end up looking really goofy, right? It would end up looking in the game where, there it is. I gotta make sure I copy the right one. So in the game, it would end up looking like this, as some sort of repeating texture. It would be side by side. That doesn't connect very well. Well, a tiled sprite does this. It builds another sprite in a row. So all of your middles, for those that needed that visual example, will look something like that. So going back into here, we have all of our corner pieces, perfect. And then we have the bottoms which these are technically repeatable middles. And we also have, where did I put those? Sides? Sides, yeah. The sides, which are technically the middles. And the tops. So what I'm going to do real quick is take these, and we're just going to pull them out. Oh, when I get back into that file, I'll do that. So for now, we're going to pick the one that has soil. I like the soil texture over the dirt texture for now. So we're going to put that in at 16 by 16, and we're going to call this grass, soil, top. Now, I do snake case with this capitalization format. I use the C programming whenever I'm dealing with tile sets and objects inside of Gdevelop that need some breakdown so we can visually see what's going on. So here we are, we have grass, soil, and we're just going to duplicate the name, and we're going to hit apply. Now, out of the gate, if we drag this onto our game world, and I now drag it left and right, we can see that oh my goodness, I got hiccups. We can see my phone is ringing. Hold on. I've left it over yonder. All right. Sorry about that. That was important. I gotta have my phone on me. For those that don't know, my mother had a stroke, her third stroke in her life, and I am in charge of all of her health stuff. So I gotta make sure that my phone is nearby, and that's why I haven't been on live as often. So I apologize for all of that, but life comes first. We gotta take care of that stuff. Okay, so coming back to our game, we're gonna set up our grid into a 16 by 16 format, and the reason why is because we wouldn't be able to see when we show our grid the scaling of our objects unless we snap it to grid. So a good way to get started is to start with by enabling that grid, and we're going to just kind of stretch our material across the bottom. So now we have an area for our player to run, but to use that effectively in Gdevelop, there's a couple of things that we can do. I want the tile set itself in this game to be the collision boxes, so I don't need to add, like I have in other examples on how to build platforming tile sets, to have a collision layer that are just collision blocks. Instead, we're going to do this a little bit differently, and we're just going to double click on our tile set. We're going to go to behavior, we're going to add a behavior, and we're going to add the platform behavior. We want to turn off the ledge grabbing and just make sure it's platform. Here we can do jump through platforms and ladders. So this will come in handy as we develop our game. So we want to just disable ledge grabbing and start with that default thing. Now, that means that when we add our player now, the player won't fall through the map, okay? Because without collision, it's just a picture. So we need to start with some collisions. So now that we have the collision, let's see here. Now that we have the collision, we need our player. So we're going to go to our object, we're going to add a new object, and we're going to click on sprite. So now this is our toast sprite. So this is our main player. You can name it player if you want. I'm going to name it toast. And we're going to import some images. So we're going to start with a new animation. On animation 0, we're going to call this idle. And we're going to start with a capital. This is really important. We're going to go to our sprite and add a sprite. We're going to go back to our super toast world, into our sprites, into toast, and we're going to start with the idle animation. And it's just idle 0, 1, 2, and 3. There's only 4 frames here. So we're going to hit open. And I'll add them in. So now we have that. And I think that at the very beginning, we have to make sure we loop our idle animation, or only play once. I think that's a little fast. So what I like to do is break that down to 11 frames instead. And we can see even that might be a little bit too fast. Let's go down to 10 frames. I think that's a good beat to see our character bouncing. So we're going to do 0.1 as the current timing. So you control that now with 0.1. So with 4 frames, 0.1 is roughly 10 frames a second in the animation cycle. We're going to add another, and we're just going to call this move. Anytime we move our character, we're going to play this animation. This is also a looping animation, but we have to add the sprites first, and we're going to go to well, I guess it's called run here. So we can rename it run, just to keep it consistent. So we have idle, run, and then we could, while we're at it, might as well add jump, right? We know we're going to need to do that eventually, so we can just prepare our player in advance, add the jump, and go back into here, select our jump frames. There's 4 of them as well. And on all of these, except for the jump, we're not going to loop the jump, but we want to make that 0.1 as well on the run. And that gives us some consistency between, what the heck? Some consistency between all of the frames. So we have a cute little running animation there. We're going to check our collision masks just to make sure that nothing goofy happened, and it doesn't look like anything goofy happened, so that's good. We're going to check all of our jump frames. All right. We might need to do some adjustment to the frames here, because if we hit something like this, this could mess up and hurt our character to some degree. So we're going to consider changing those frames later on. But we are going to start by changing the origin of our character. So we have an origin and a center point for all of our stuff, because we know that this character is 16 by 16. If we move our point over into 9, that's too far. We actually want to move this X point in the center to 8.5 rather, which is due center, and 8.5 on that as well. Because technically, right, in the 16 by 16, 8 is properly in the center, but there's no, because it's even, there's no true center. So we have to move over to the half. If we want it to be perfectly in line, you don't have to do this. I like to do it just to make sure that I'm in line, and I'll follow that line, go all the way down, and we'll go down to the 16 position and 8.5 for the origin. Now, this means our player is spawning on the origin. This is really important for a lot of other things that we're going to do later in our game, including checking for collision at certain locations. So we're going to go ahead and put our jump in, or not our jump, leave that point, and it'll be true for everyone. So as it is right now, even in our jump animation, that origin point is going to be the same. And this means that all of our art will be spawned at the same position. So if it's supposed to do something like this, it'll now do it at the right location. So, all right, enough of that. We're going to add our toast to the game. Anywhere is fine in the canvas. We're going to put them right in the middle, and we're going to add a behavior to this character. So by Alex, by double clicking, you'll be able to open up the behaviors, or the object. Okay, by double clicking on the object on the canvas, the instance, you'll be able to open up the properties panel. We're going to go over to behavior, add a behavior, go to platform character, and we're going to disable the default controls. So I know how I want this character to run and move already in the game. So we're going to just duplicate over some of those behaviors. So we're going to start with our game control, and we're going to leave gravity at the same, and we're going to go over to our falling speed and change this to 500. Our jump speed is going to be 350, and we're going to sustain this for a little bit while longer than it suggests, because Mario has a bit of a floaty system to the way it works. So we're going to change our max acceleration up to 200, and we're going to de-accelerate at the same speed at 200. There is no grab tolerance. We don't need that, because you can leave it. You just turn it off. We're not grabbing anything, so you can leave that as 10 if you want. And then we're going to move down and make sure that our slopes are selected properly. We can go through jump platforms. We're going to turn that off because we don't have any jump platforms currently that we can fall through. And we're going to set this to 150 on that speed, just in case we change that later on. The advanced options are depreciated, so we don't have to do anything else there. And we're going to hit apply. So out of the gate right now, if we hit preview, we're going to see our character fall onto the screen, make it large so you guys can see it, and nothing else works because we disabled the main key input. Now, the reason, even though that technically speaking, the global settings that we set are the same as the default settings for the platforming behavior, so these keys are the default keys. We want the player to be able to change this over time and change it to their own liking. So that's why we're doing it this way. There's a couple tools we can use to remap keys if we wanted to, but I like doing my version. So do what works for you. Another thing that we're going to need for our player character is a state. So we're building a finite state machine. So we need to add a variable to our object. And so this is a toast, the toast instance, but it's all objects when you double click on it. So this will change it for everything. That's important to know, right? So once we go in here to change everything, we're going to create a new variable and call it toast finite state machine. Or we can just actually even call this state. What is the toast state? And we're going to start it off with init, which is initialize. It's going to be a string. We're going to control all of our player movements by rotating through the strings, by changing the strings. And this allows us finite control over our character, finite meaning very restricted, very limited control. This is a great project and a thing to use for when you are trying to build a more polished and more robust game. So we're going to start with that. I'm going to hit apply. We're going to go into our game scene events because this is where we begin the very beginning of our programming. So, and I know that when I say programming, we mean like pseudo programming, right? Because Gdevelop doesn't have necessarily a programming language. It is a visual programming scripting event system. So, to make that work, we need to begin with developing a external event. Now, for those that don't know and maybe playing or using Gdevelop for the first time in this series, you have things called scenes. And scenes are a complete... So right now we have the untitled scene. I'm actually going to hit F2. You can also click on the dots and do rename if you want, but F2 is the quick hand key. After you press F2, you can... we can name this game scene. So now we have our game scene. Now if I hit enter, it's going to close everything, and that's fine. Just double click it to reopen it because we're still in our game. A game scene consists of a layout, which is what we see here, and a game scene event script. Okay, so when we add an external event, what we're doing is adding an external sheet that looks like this. And when we add an external, whoops, misclicked, my bad. Let's go back into my game here. Hello. Oh, it moves screens. Okay. When we go into our... I lost my train of thought. Where was I? Hold on. Oh, when we go into our project manager and look at layouts, what we see is this here. This is a layout. Now, when you create a layout, or a new scene, a new game scene, it pairs both of these together, but they're stuck together. You can add other layouts and other event sheets together to create a cohesive program, right? And if you create though a new game scene and your objects aren't global, they don't share the scene objects. If you want your scene objects to be accessible in other event scripts, when you create an external, so we're going to create an external event, we're going to call this player finite state machine. Okay. When we open the player finite state machine or any other external event, it's going to ask us to choose a scene. What it's asking you to do is link this together and pull all of the information from that game scene into this event script. So we're going to be now linking these two things together. So they are technically linked, but now we need to trigger them to happen. Okay. So the first thing that we are going to do for that development is starting on some very basic features in the actual game scene. So when we right click on the new events, we can create an event group. And event groups are really handy because if you right click on them and edit them, you can change their color and customize them as you wish. So at the start of my game, I like to use blue, a light blue or a teal, as the initialize setup. So I want to do init the game. So initialize the game, init the game. And also that white text is hideous. So we're not going to use that color of green. We're going to darken that up because I don't think I can change the actual text color. There we go. Initialize the game. I'm going to duplicate this a couple of times, and we're going to edit the next one and turn it back to that default blue color, actually. We're going to use that for now. And we're going to set up all of our game mechanics under these. So the first thing we need to do is set up the player finite state machine. And what we're underneath this, if we hold shift, and once we click it, hold shift D, it creates a child. Now, I want to say it's alt D, no, control D, D, what is it? Edit, add, oh, shift A for a new event below. Okay, yeah. So shift A goes underneath as its own at the same level, and shift D is under as a child. So we're gonna make a child. Every time I say child, shift D. Okay. So we're gonna make a child. Got to calm down here. I don't know why my mouth isn't working the way it usually does. All right. Once we create the subscript, the subchild for player finite state machine, we can actually right click on this little tab on the side. We're going to add, and we're going to link an external event. And now we don't need that child anymore, just this one. This allows us to include an event, and we're going to link the player finite state machine over. So now at the beginning of the game, no matter what happens, these are running every frame. We're checking to see if this file is there constantly. And so this is roughly done 59 to 60 times a second. And so that's kind of the default engine mechanic, right? So knowing that this is constantly running, so it's checking if this is existing, and if it does, initialize whatever's in here. Well, we're going to control all of our player code and branch in and out of the system, and so we need to be able to link to that. Another thing that I want to do is we're going to duplicate this because we're going to need to follow the same format. We can call this camera manager. So normally I do stuff like this. Camera manager, that can go on top. That's important. We don't have a camera manager script yet, and that's why it doesn't show up. So we couldn't even type camera manager. So this would actually do nothing because there's no external event. We can create it here. Okay, we're going to link together the camera manager. You know, there might be some other setups that we want to do later on, but for right now, we're just going to do the bare minimum. And we're going to do another one called Object Manager. So Object Manager, and this will be Object Manager. Right. So because this reads kind of like, if you have any programming experience with things like CSS or cascading styling sheets when you're doing programming in HTML and JavaScript, you'll use CSS. And in CSS, you read from the top down, and whatever the last thing is kind of put, that's the last, and that's the priority, right? As it goes down, it overwrites itself as it goes downwards. So having things, but what happens first is at the top. So it's really important that we start structuring from the very beginning, knowing kind of what order we want things to run in. We always, to avoid issues, like our player should be amongst the bottom mechanics of our game. We generally want user interface and inventory control and everything else to kind of be on top of that, to supersede perhaps even player movement. It's up to you how you format them, but the way that things are formatted in Gdevelop do matter. So we'll consider that as we continue programming. You don't need to stress about it now. I just want to make sure that you're aware of this. So with that in mind, let's start developing the important parts of our game. So I think arguably, rather than, setting up, fine-tuning a camera movement, for example, we're going to start with just the player finite state machine. So we're going to boot up our player finite state machine, and we're going to create a new, that is the wrong button, Alex. I'm proud of you for clicking on the wrong button. Is an event group. And we're going to do this a couple of times. So the first thing we're going to do is init or initialize, right? Player, or in this case, toast, or object, whatever you want to do, right? Could be any of these. You do you. So we're going to say initialize the player finite state machine. So now we want to initialize the player finite state machine. Earlier, we set the player object to equal initialize. So the very first thing we're going to do is check if the player's in the initialized state. If the condition is if the player, and where you can just type variable, if the player text variable of state equals, in quotes, INIT with a capital, then we're going to do something. So when the state is active, when we are equal to this, always run this. So check this every second. And if this is true, we're going to initialize the very first thing, the very start of our game, or for our player script. So we're going to initialize our player. We're going to link an external event, and we're going to now create it. Now, this is an optional step, but it kind of teaches you the fundamentals of how a state machine works. So if the player state is initialized, let's begin. This is kind of an empty script mostly, but I think it's good practice. So player finite state machine, and we're just going to do INIT. Player finite state machine, INIT, that's the script name. So from now on, the naming convention is player finite state machine and the action what the player is going to do. Hopefully that makes sense to you guys. So we're going to now access it. So if it isn't in the dropdown, that means you haven't declared it or created it. So now that it is in the dropdown, we can click on it, and we're going to launch into that script. It's going to ask us again what we want to include it in, and we're going to say the game scene. Now we're going to structure this as though it's the same finite state machine, the same format we're going to use for everything else. And I like to develop it like this. So we're going to create a first one, and we're going to edit this, and we're going to make this green. Okay, maybe even darken this up a little bit. We're going to call this actions. These are actions that you can do while inside of the state. And so we can even, just to add some, if you want to add a comment, you can add a comment over here, drag it into your action, and this is all actions we can do while in the init state. Okay, and this is transitions. And I like my transitions to be red. So this is just to kind of give you some color coordination and help you out. So transitions is red. And these, we're going to copy that comment, Control C, Control V, move it back into this. And all the transitions to leave the init state. So this is like when we first load in, right? Let's break this. Let's add one more group and call it first load. So every time, or actually on load, think of it like a function. So on load, when we load this function in, we need to decide what it does. So normally in another external event, I might load in here to change the animation to something else. What actions we can do in the animation or inside of that state. Sometimes it's movement, sometimes it's doing nothing like idle. And other times it's when you press a key, what happens? Well, at the beginning of the game, because we load into a debug state or an initialize state, we can check to make sure our program is running by simply checking this one feature. So we technically have nothing going on here. We can close the onload and actions down, and we're going to leave the state immediately. So basically, when we load this in, because we already know that the state is true, like we don't need to call it again. Anytime that you run a script in Gdevelop, you want to put the parent at the top level. So looking at this from the very beginning, we can see that in the game scene events, we have a player, finite state machine, script, but that's much like building a player, or sorry, an event group, right? And a parent and a child node. So that means that the player finite state machine is a child of this script, right? So we build into this. So this is a child, which means this runs first. Because this runs first, we pop over, and now it's looking for code to be initialized. So we can just say initialize the player, for example. Initialize the player. When the state is initialized, because this is a child,
this already is true. So we don't need to ever check if this is true in this script because it has to be true for us to be inside. So if this state is initialized, we go into that and all of these actions are now accessible, right? But we're not doing anything here, as I said. So we're just going to say, if it is initialized, which it is, we're going to do one condition. We're going to change this over to variable. And we're going to change the player's text variable right here from state equals initialized to idle. So we're leaving this now. And the only reason why we do this is to check the player's debug state. Now, before I show you how to program the actual movement, I want to go back to our game scene. We're going to duplicate our camera manager, and we're going to call this debug manager. And we're going to do the same thing. Change this to debug. Oh my goodness. Debug manager. And we're actually going to move the debug manager to the very bottom. And because everything's going to run first, the debug manager runs last, which means it'll have the most up-to-date code in a top-down structure. So with the debug manager, I got hiccups again. Forgive me. We're going to go back into here, make sure it's set, and jump over to it. Select the game scene. And we're going to always do something here. So in the debug manager, we're going to create an event group just so you know what kind of to organize what's going on. And this manages for debug text. So manager for debug text. We're going to create a child and every frame. So there's no condition. We don't need to check if anything exists. We already know that the text object exists because we've manually put it in there. So now if the condition is true, or which means that it's just running at this point, then we always want to do something. We want to take our debug text and we want to change its actual text value. And we want to set it to something. We want to set this to a string called state. And we're going to add a colon, a space, and we're going to end it. So this is a string. So for those that are coming from another language or want to understand what's going on here, we're passing a text string and we're combining it in quotes. The reason why we add a space is because in a text string like this, a space is considered an empty variable. So it needs to it passes through that actual physical space key. And so that way when we go to print whatever this text is, it'll include that space in what we're doing. Now we can continue here and actually add some programming logic inside of this text variable state. And you add the plus symbol anytime you want to add another string. So if I added state plus and filled something in here like, run, it would always be the state adds the run afterwards. So it's and print this, okay? So when we do the and print feature, print this additionally, on the same line, we want to add the next feature. And to do that, we can actually access a variable from another object. So we're going to access the toast character, and there's going to be some variables assigned to the toast character, and it's toast.state. Now, because toast.state is already a text variable, we don't have to wrap it. Sometimes you might expect that you might need to pass in to string and then wrap the object, so that way you can pass through this string of state. We don't need to do that because it's defined in the player object variable as a text condition. So toast.state will work. And now when I run the game, we go back to our game scene, click preview, we'll see that our current player state is equal to idle. Well, now we know that our finite state machine is working. Why? Because this changed to idle. Forgive the blurriness, but this changed over into idle. Before, the player state was initialized, INIT. Now it's idle. So we know that that script is working. Perfect. We know that we're now entering an idle state. But we don't have any logic for what happens when we're in idle. So we now need to go to our player finite state machine and copy the initialize the player, right? That's kind of what we were doing here as an example. And now we need to change this over to idle. That's it, or state idle, just to help you. And to do that, we now need to check whether this is a condition. If the text of state if the text variable, if the string of the state of object toast and is initialized, then do this. Well, now it's idle. Okay. And then again, player finite state machine. We don't have an idle. So we're going to go down here and create them. So now we know that we need the player finite state machine idle. And we might as well make a few more so we don't have to come back here. Player finite state machine jump. Okay. Player finite state machine run. And I realized here we got to make sure that we keep this consistent. Let's make that a capital P. All right. And we're also going to have a player finite state machine for falling. So fall. And these are all the different states that we have in our game that allows us to kind of change what keys we're allowed to press at certain times, make sure that when we're falling, we're not also allowing ourselves to jump in the air. And this is how we sort of break that down in a player finite state machine format. So now I don't need to initialize that yet. We're going to go back into here, go to our player finite state machine, and we're going to call this idle. Oops. Hello. Idle. There we go. And we're going to duplicate this a few times so that we don't have to redo this. So we're going to go idle and change this over to run. Player finite state machine, as you guessed, run, right? Same thing, all the way through. Jump, whatever your actions are. This is what we're going to do. So I'll let you guys do that on your own. Run, jump, we're going to have fall. Okay. Idle, run, jump, fall for now. And we'll add in some of the other features later, like attacking and everything else. So we're just going to make sure that all of these are to the right name and fall. Okay, so again, because this player finite state machine is running every frame, it's checking whether this is true. If now we're checking these conditions. Okay, so I'm going to collapse these so you can kind of see what's going on here. So we're now checking if the text changes in real time. If the text changes from initialized to idle, run this script. And now, because we have this initialized format, what I'm going to do is I'm going to copy this, and we're going to make a template, just so I don't have to redo this. So player finite state machine temp for template, or whatever you would like. Choose the scene, add it back in, and all we're going to do is paste the previous objects in here. So now I can just copy them, holding shift, clicking on each of these, Control C, and now we can move back over into whatever our next stage is, which is going to be our idle state. So now with idle, we link it and we paste it. All right. So now we're going to utilize this format from the very beginning. So with the idle state, on load is whenever we enter state. You could also change on load to enter state, just so that you know what's going on here. So when we load in the idle state, if the player and animation, we're actually going to start with an animation keyframe. So if the animation, we can do by name because we know it's idle. If the player is not in the idle animation, and so right now it says is if this is true, if the player is in the idle, then do something. But we want is not. So we can click on it, press J to oh my goodness. We can click J to invert it, or we can go in here and click invert condition. So if we enter the state and the player is not idling, set the player to idle. Player animation, idle. Oops. Animation, come on. By name, set it to, I got ahead of myself, set it to idle. So condition, action. We could do this once, right? If we wanted to. If this is true, when we enter the state, do this one time. If it's idle, make it idle, because we know that this is looping. So we technically don't need the trigger once, unless we want the game to not continuously check this script. If this is a trigger one time, when we enter the script the first time, which means when we leave it and come back to it, it'll trigger again. So if we're not in idle, say we're in walking or running, and we enter the state, trigger this one time, and not continuously trigger it over and over and over again. We want to maintain our resources, right? So in this case, we could use a trigger. It's probably a better idea in that regard. So we're going to onload, and now what can we do while we're in the in this case, it's not initialized anymore, it's idle. Okay, and I'm just going to do like quotes, so that way I know every time that it's kind of like a template that we're going to be reusing over and over again. So what can we do? What actions can we do inside of idle? Well, nothing, actually, because if we do anything, we need to leave the idle state. So transitions are leaving the state, or just leaving state. There we go. All right. So if we're going to leave the state, what happens? Well, we need an event that is underneath the transitions, and we want to check for input. So if any of this is true, so if this is true, do something, leave. And so we're going to start with our run. So the very first thing we want to do is check the condition, and now we're going to type key, because we want to look for an input press, right? And if the input, and we're going to be looking for a text expression, okay? If pressed, we're going to say okay. And in here, we can pass through some amazing values. So we're looking for a key being pressed, and it's looking for a string, right? So if I wrote up, for example, like this, okay, it would be expecting the up key to be pressed, the up arrow key, right? But we're not going to be doing it that way. Instead, we're going to be looking for, because we made it a global variable, key bindings dot controller, or keyboard, sorry, and then we're going to be looking for the movement keys. And for us, left and right are the movement keys. So if left or right is pressed, okay, now we're going to go to right, is pressed. So if this happens, what are we going to do? We're going to leave the state. We're going to press the toast. We're going to type variable, and it's a text variable, and we're going to change state equals from idle to run. All right. So whenever the key is pressed and we're in the idle state, immediately transfer over into the run state. That's all we got to do. We'll leave the state. And so what happens here is if either of these are true at any point in time, and so this is both of them, right? So if either of these are pressed at the same time, we'll do this. So we need to add an or statement. So we add the condition or. Now we say if left or right key is pressed at any time, now move to the run state. And what we're going to do is right click on this, create an event group. We're going to bring it up and tuck this in, and this will be to run state, right? Transitioning to run state. If any of these are pressed, we don't want to trigger this once, because if the key is pressed and it skips a frame or something happens, you'll have to touch the key again. So to make this as fluid as humanly possible, we're going to say run, we're going to move over to the run state. Perfect. So now if I preview the game and I move the arrow keys, I move to the run state, but it doesn't change back. And I don't actually move. Well, that's because there's quite a lot going on here, right? So we can digest this as, okay, well, I went to the run state. So let's go back to our finite state machine, go to our run state. It's going to run, but nothing's happening. It's because it's empty, right? Well, obviously, clearly empty. So we're going to go back into our, I don't know, I closed it a minute ago. I should have kept that open. But we're going to go back into our temp file. And again, copy all of this. And in fact, because this has actually been updated by the idle, I'm just going to copy these again and update these, because there's some changes that we made that I think would be good for us to keep as a blueprint. So now to the run state, we can actually disable this. And we'll pull this out in our temp, because we may need to transition to the run state later, and we can just copy it from here. So we're going to keep everything in this beautiful temp folder. I press D to turn it off, but you actually can just leave it on. This is never being called in our game. It's just an empty script that never will run. So we can pull and organize to the best of our ability inside of here. So we're just going to delete that. And now every time I copy and paste this, right, we don't have to go through this arduous cycle. And it's actually okay to leave this up here, because when we now copy it and move it over to our next script, which is run, we can paste this and just check when we, paste it upside down. Let's make sure it's in the right order. Now we can check if we're not in the run, change to run. That easy, right? Trigger this once. So if we're not running, now start running. Let's check our game. Hey, look, it worked. He's running. He's just not moving anywhere. But he transitioned from the basic movement to now this movement, or for his idle to this movement. Okay, so actions. This is where it becomes a little bit different than before. Inside of our move state, or in our run state, right? We entered the run state, we're now running. Now, we need to check for if our key inputs are being pressed. So now if, in this condition, if we enter the run state and we're running, and the key, and we're going to go back to do the key expression, you could go back to your idle script and copy from here if you wanted to, Control-C, not the whole thing, just one at a time, Control-C. Move it back over to run, paste it. If the keyboard of run left is pressed, right, what are we going to do? We're going to simulate the run key. So toast, then type simulate. So down here in the player platformer controls, or you can type sim if you want, or simulate to get them all, but they're right here. Just scroll down, simulate the left key press. Now, if we trigger this one time, you'll only move 1 pixel. You'll move for a split second and it'll turn off. So we need to leave it on. And we're just going to duplicate this, copy this, do right key. And these need to be 2 different actions. So let me minimize this so we can kind of see what's going on here. So what we're going to do is on key left, move left. On key right, move right. Okay, let's go back to our game. So now on left, we move left. And on right, well, we move right because I didn't change, or we kept moving left because I didn't change this over to right. So make sure that you change those appropriately. So now left is left and right is right. So left, right. And there's a little bit of a slide on our character when you let go. You may be noticing this in your own game. So left goes one way, right goes the other. There's a bit of a slide. And that floatiness is pretty close to the retro format of movement. There is a little bit of a float to it, so that way you can kind of use momentum and carry your character across the game. So now that we have this, we're able to move left and right, but we don't leave the state. It's expecting us to keep running this script because we haven't left it. So now we need a transition. So what we can say is we can go to our idle, and we're going to copy this to run state, right? We're going to paste it into here, and we're going to say to idle state. Oops, that is not how you spell idle. Idle state. If any of these keys are being pressed, go to the state. Well, we need to change some of this, right? Change this to idle. And now we need to say if one of these conditions is true, and we don't want one, we want all of it to be true. If left key, and we're going to invert both of these, so shift to select them both, press J, and now we're inverting it. If not, if the keyboard right is not pressed and the keyboard left is not pressed, and I know we're going to need a few more, and the space key or jump key is not pressed. Let's go to jump. Okay, let's go to jump, please. It's being weird, so I'm just going to manually... Okay. Hello? Can we not do that right now, please? We're just going to go to jump. There we go. So if the jump key isn't pressed, left and right key aren't being pressed, switch over to idle. Right? So let's go back to our preview. Go to idle. We're going to move left. And when we stop moving, we actually see our state return back to idle. And what happens is we can tell our idle script is working because we're going back into the idle animation. So running, and no longer running. All right. So we have the very basics of our game. We can't jump yet. That's okay. But we can move. So that's, hey, listen, that's like 90% of the battle, right? Like we've done a lot here. So congratulations on getting the basics of your finite state machine in order. I hope that this makes sense to you, because by building our game in this format, what it allows us to do is micromanage, and again, because it's called a finite state machine, a restricted, limited control machine. And what we're talking about is by using a variable to control these actions, we change a simple text to then control all of the outcome. We keep coming back to the finite state machine start as every one of these changes, and it allows us to dictate how we're going to control our game as we move forward, right? So now, every time we enter the run state, only what happens inside of run can be done. So even though jump is a key that we're going to be adding to the game. If I don't add the jump key to the transition state when I'm running, I won't be able to run and then jump. Now, if you're developing without this technique and you're using the jump key is pressed jump, then you're going to end up running into tons of issues in your program where your character is able to do things that they shouldn't be able to do. This is how we restrict them, control what they can do in each action. So we're going to keep building this, and hopefully it becomes more self-explanatory, because I'm going to do less talking as I build this next feature. And something I would like to make a note of before we continue here is that a game is just a bunch of features that are tied together in end polish. So whenever we build a feature, you're one step closer to finishing your game. So what I'm doing right now is I'm writing what I like to call components. Components are small they're aspects of a feature. They're like a child of a feature, which means that you build enough of these together and they become an entire feature. So we're building the player finite state machine feature, but I'm building all of its base components now. So we've got the idle component in place. We've got the run component in place. Now we're going to keep building on these until they're a finished, polished feature. And once you've done that, you're done with it. The nice thing about doing feature building and building it in this way, okay, of course you might do some fine-tune adjustments, but the reality is that once you're done with this script and it does what you need it to do, you're done with it. You don't have to do anything more with it. And we can keep it organized and separate. And so that way it doesn't, create any bugs or issues in your game, long term. So although this is longer to do now, in the future, you'll thank yourself tenfold, I promise. So now we're going to go into our jump script and we're going to start jumping. Okay. So here is, again, we're going to go back to just duplicating what we had before. So going back into the temp section now that we've copied it, going into our jump and pasting it, reformatting it, because every time it keeps doing that. Not sure why. And now we can get started here. So on load, as you might imagine, if we're not jumping, please jump. Please set the animation to jump. And when we are in the jump state, this is the one action where we're going to do something that, this one's a little confusing. And the reason why I do it right after move is because it is a little confusing. And because it uses some scripting that's involved in your run or move script. Okay. So the actions that we can do, I'm going to now create a new event group, and we're going to call this action movement. So, and the reason why I waited here, right, is we'll do horizontal movement. So when we are running, we can do horizontal movement. But also, as soon as we enter the jump state, if we don't allow ourselves to, inside of jump, add the action of horizontal movement, we won't be able to control our left and right air acceleration while we jump. It'll just jump straight up. We won't be able to hold left or right to move our character. That's very rigid jumping. We don't want that. And so that's why in jump, it's one of the only actions where we'll end up taking something in this format and moving it over to another script inside of the actions area. Now, if you're building an RPG and you want more actions, so like dashing, you'll have to add dashing, double jumping, all of those actions in each state you want it to be accessible in. Because again, when I press the space bar and I'm in idle, it does nothing. It does nothing. There's nothing going on here. There's nothing for space bar to do anything with. I now currently need to be in, well, currently we've got no jumping. So where do we want to jump? Anywhere we want to jump, we have to add the new jump script. Oh my goodness. Sorry, guys. My phone is blowing up. I just got to make sure it's not family text. All right. And it was actually. That's important. Okay. All right. Now, what I mean here in the actions is that when we right click and create a new action and create a new event group inside of the actions, we can now create the jump action. Okay. Now, jump action is actually a transition. So I don't know why I did it that way. That was silly. So we're going to copy this one and we're going to keep it consistent. Come on, Alex. To jump state. Now, because in run, we want to be able to jump. And in idle, we want to be able to jump. We have to build out the state. And it's simple. And we just say copy, paste, and reinvert. So when the jump key is pressed, guess what? We're going to jump, guys. It's that easy. Jump. Okay, now we want to transition from in the idle. We want to be able to do that. We also want to do it when we're not running. So sometimes you'll want to jump from standing completely still. So we're going to add that here. So to run, to jump. And now that we have it in both our idle state and our jump state, we need to actually go to the jump state and add in the to jump feature. So we're just going to call it jump. And now we're checking if this key is still being pressed while we're in the jump state, we're going to trigger a jump. And we're just going to go down to simulate the jump key. So jump, simulate jump key. All right. So when we simulate the jump key, now no matter where we are, I can be standing still and jump, but now I'm stuck in the jump. And I can move left and right, which is kind of strange, right? As we talked about before, because we don't have a state to transition back to idle, right? So the reason why we're not leaving jump is because there's no transition. So we need to go back to our run, go to idle, and paste it in the state. So if none of the keys are being pressed, including the jump key, because we still need to check if jump is being pressed, then we're going to transition back to idle. Perfect. Now, because we developed that to run state, we can paste to idle state in our temp folder, and we can do to jump, right? So we have to run, to idle, to jump. All of these are now accessible for us to copy in our transitions. And so I'm just going to start packing those in, because now we can change them as we need them, delete them and move them around. Horizontal movement, we can now add to actions, because maybe that's an action we'll need in another state. Maybe we don't need jump, that's specific. So now we have movement, idle, run, jump. Those are all transitions. Perfect. So now, when we run our game, we can idle, run, idle, stop, go to idle and stop. We can jump and go back to idle. We can jump, move, and now because we're using the movement keys, I'm still in the jump state. So what's happening there? It's because the movement keys are still being pressed even after we've jumped. Now, we only want that to be controlled while in the air. So in our jump, I'm going to move the temp to the very end so that way I don't get confused here. So in jump, into jump, when the key is being pressed to jump, we jump. But in horizontal movement, when these keys are being pressed, no matter when, continue to move. But moving is technically a move that we want to do in the move state. But while we're in the air, we don't want it to move to the move state, because that'll mess up tons of other stuff. So instead, while we're moving, we want to check a new condition. And they have a very convenient platformer state. Oh my goodness, I got hiccups. In the finite state machine. And we can say, is jumping. So, is not on floor, effectively. Is jumping means it's in the air. So we can just say, is jumping. So if the player is jumping and left is pressed, or is jumping and right is pressed, do this. But then, when we land, go back to idle. You could also, another way to do this is to build the move state, right? So going back into our temp, we're going to go back to run state, and we can go into jump, paste it right here to run, idle to run. And now when these keys are pressed, go to the run state. Okay, so got kind of some conflicting things happening here. So now when we jump, we are running, but we don't want that to happen. So now we need to do a conditional state. So either while jumping and these are happening, do this, but to clean this up, we can do something else. In the condition tree, if the toast is on the floor, if the toast is on the floor and these keys are pressed, so the first condition is not part of the or statement. You must be on the floor to enter the run state. On the floor and these keys are being pressed. So now when I jump, I'll still be in the jump state while I move, but even if I'm holding the key and we land, then we see we return back to run. Okay, that's really important because now we can fall. Now when we're jumping, we can fall even while we're moving, and that's a whole nother state. And in fall, maybe we want to be able to ground slam while we're falling or while we jump. And so rather than adding a false state, which I would probably normally do in any other, like a Metroidvania or anything like that, where I want more finite control, I believe that in this simple platformer, it doesn't make sense to make a fall unless we add in like air jumping or coyote time and things like that, which we may do. But for now, the fall can be a part of the jump, because as we fall, we may need to do an air jump, or we may need to trying to think in Mario what would be the conditions where we might need to do something. Oh yeah, ground slamming. So in Mario, you can twirl when you jump, and you can also slam on the ground to break things. And so we're going to be adding all of those into this game, and jumping is going to get modified as we go here. So we have our basic conditions into place. So that allows us more or less to begin doing some of our other conditions. And in Mario, we have more advanced player movement, and I want to wait. I want to get through a couple extra things before we add that feature in, the sliding mechanics, the hitting enemy mechanics and stuff like that. So one of the other things that I think is really important that we start fundamentally getting into our game is some camera movement, of course. So as we get back to our camera, going to go to the initialize game scene, go to camera. I realized that Riley was saying something, and I wanted to read that. So we're going to take a brief pause here in the lecture, just so I can treat the community that's here, and then I'll get back to what I was doing here. So let me read, and then I'll get back to this. Okay, so Riley, I have in fact played Grounded, and I do like the accessibility features in that game. Absolutely, that's really thinking like an engineer, and that's the sort of stuff that my job has always been. So as a person who works in user experience research and design, people hire me to have the discussion about what is good practice and what isn't good practice, right, in development. And part of that is making sure that marginalized communities, people that are not considered, generally disability, people with phobias and things like that, get ignored sometimes in development. So my job is to remind people, hey, there are people out there who would like that feature. Can we please include that in your development? Because it's good practice, right? That's my job. So can I offer a piece of advice to upcoming game developers? Absolutely. Use a game engine. Please use a game engine unless you absolutely have to avoid a game engine. Do not use a game engine for a little project. I'm not using a game engine for a little project. I'm not even rendering anything or getting input, and I want to give up. Yeah. Okay. It took me a second to understand there's two thoughts that's happening there. So Riley is saying you should probably use a game engine because they've built the wheel for you. So we're going to break it down into caveman logic here, right? So the wheel, that was a big invention because we can now travel and move things quickly, right? Because wheels. And so why would you try to create it from the ground up when there's all these solutions in front of you that do it for free, that do it easy, that they've made it easy for you to do these things? The answer is you should use a game engine, because not using one is very complicated. So if you're considering not using a game engine, you're probably in the wrong place for YouTube anyways. I'm using a game engine. I think it's ridiculous if you don't. So find the engine, GEL, find the game that you want to make, the engine you want to make it in, and learn the languages that are applied to that engine. It makes it very simple. Now, if you encounter a visual designing, language technically, then that's excellent. That's for those people who have, like, I use visual scripting because I have dyslexia. Dyslexia makes it very hard for me to do certain tasks while developing. And so by focusing on those things, like focusing on a language that works for me, I'm able to program and get, do I feel less because it isn't a hard scripted language? No. Can I code in JavaScript and HTML and other languages? Yeah, it's just harder for me. It takes me more time. So I'm about being efficient. And for me, using a tool makes me more efficient. So I think that it's good for you to not be stubborn in game development. We make the games to the best of our ability, and that's what matters. Anybody can make a game. Anybody can. All you have to do is focus on making a game that is within your ability to make. Do it any way that's possible. It doesn't matter if it's loopy and spaghetti code as long as it works. If it works, it works. That's all that matters. So do it to the best of your ability, but you should probably use tools that help you do that. Don't get frustrated. You're going to give up before you even began. So don't do that to yourself. All right, let me take a drink here and refocus, and we're going to get started on the next part of this. And so again, I'm going to get kind of quiet and focus in towards doing this education so we can edit the video and make all of these parts come to life. I'm going to be focusing until the game jam starts, completely finishing this project from the ground up and making videos for it. So we'll have a couple months of content rolling out after these live streams go. So I'm very excited for that. So give me a second here and we're going to get moving forward. Actually, this is a perfect time if you need to, guys. Take a bathroom break. Take a moment, get up, stretch. Okay? We'll be right back. We'll be right back. Okay. And I'm dying here a little bit. Choked. My water. My eyes are watery. Oh, God. Okay. Okay. All right. Sorry about that. So, yeah, good point, Riley. Thanks for contributing that stuff into the chat, man. Absolutely. That's great advice. Okay. So, I was thinking about what next we should add, and I was thinking about going into the camera manager. And, well, absolutely, Riley. Take whatever break you need, sir. So, in the camera manager, we actually only have a couple lines of code, and before we get there, I think this would be a perfect time to add our extended features that we're going to be adding to our game. The polish and extra bits that I want to add to this game to really make it feel like the retro games that we're trying to emulate. So let's go to our project manager, and we're going to move down to extensions. So if you've ever done a behavior, which we've already done previously in the series, then you'll be familiar with how extensions work. Those are all extensions. So each extension you add adds various actions and conditions to your game. So we want to start by, of course, adding things like gamepad controllers, because we do know that we want to add something like that. We want to add, I'm going to add something called Parallax. So I also, just in case you haven't, make sure you have show community extensions that aren't officially reviewed enabled, please. This will allow you to to build extensions, to use built extensions that aren't necessarily restricted to just the default ones that Gdevelop considers. So we're going to add Parallax. Okay, we have that. Let's see, we're going to need the advanced. So advanced. And we're going to be getting the advanced platformer. So we need to remove Parallax. Advanced platformer movements. This allows us coyote time, air dashing. These are the folks that created the script, so you can see that there. And let's see, I like adding one of my favorite features is the 3D flip feature. It absolutely, you'll see it in all of my development. I use it in everything because I just absolutely adore the flip. So we're going to be doing that here. And we also need room-based camera movement. All right. So now that we've got these basic extensions in place, later on we'll add some mobile ones, but for now we have these basic ones in place. We can start using them in our setup. So inside of our camera controller, what I like to do is, let's get into our camera. We're going to create some event groups to manage everything. So we're going to call this initialize camera. So this is the first thing that the camera is going to do at the beginning of the game. So we're going to initialize this with a child. So you can shift D if you want. We're going to type beginning, beginning. So at the beginning of the scene, we want to do something. So at the beginning of the scene, when this camera manager loads, because it's technically happening in real time at within the first frame of loading, we're going to start at the beginning of the scene, and we're just going to center the camera. So camera, rather. We start with an action, type camera. Camera's center on object. So there's center camera on object. Center on the player. On the base layer, with camera 0 is fine, so just leave it alone. We're going to center on toast. So at the beginning of the game, I like organizing these in steps, but this is technically the same thing as doing this. But just to keep it organized, at the beginning of the game scene, we are going to... beginning of the game scene is actually triggered once. So you don't need to say trigger, run once while true. You don't need to do that. At the beginning of the game scene, this is already happening. This is true. So this is going to run once this begins. So what do we want? Center the camera. And then what we want after that is to initialize something. So we want to make sure that when our game starts, the camera's in the right position. Okay. And then we're going to create a new event group. And we're going to call this camera zoom. Oh, no, sorry. No, camera zone, rather. Zone movement. Now, this is kind of important in maybe not so much in the direct retro format. Let me try that again. How do I want to say that? This feature that we're going to add is more of a modern take on a retro style. And so once we initialize the camera, we're going to use things called lerps and other features that will move the camera in a more modern way, but still capture the essence of retro. So we're going to use a camera room object. And we added that condition, but we don't have the object in our game. So we're going to go into our game, the actual game scene itself. And we're going to go into our camera. And we're going to start adding our camera collision. Oh my goodness. I got so many hiccups, guys. It's ridiculous. I apologize for the stuffy nose and hiccups today. All right. So going into the camera, we're going to add an object, and we might as well make it a tiled sprite just because we're going to be stretching this. But you could use a single color in a sprite. It wouldn't really matter. All right, we're just going to use the regular sprite because it doesn't truly matter. So might as well keep it as simple as possible. So we're going to call this camera zone. So camera zones, right, are a camera underscore zone because I like to keep the format They're a trigger, right? So what this is going to do is it's going to contain the camera to be able to move freely inside of this zone. And this allows us to do things like hidden camera movements, things that like your player's only alive while in collision with the camera zone. So if you fall out of the camera zone, then your player dies and you restart. There's a lot of cool features that we can kind of pad into this and do it very, very simply. So we're going to create our first sprite in this together using Piskel. This will not be available in the art pack, so you'll have to do this yourself because it's very simple and you should know how to do this. So click on Create with Piskel. Go to the width and height, and we're just going to set it to our standard width and height for our game, which is 16 by 16. We're going to call this camera zone as an object. This is the actual name of like the PNG. So camera zone, camera underscore zone.png, right? And then we are going to, actually, before I forget, set the default size to 16 by 16. And then now that we have that, we're going to go to fill. So B, if you want to just go to the fill, P for pin, B for bucket, B to fill. And then we're going to select a purple and just kind of fill that in. Okay. So now that's all filled in, we can save that. And there's no looping. So we don't need to worry about anything there. We just hit apply. And now, how did that happen? Why did that get so big? Did I mess something up there? You guys probably watched me in real time do something silly. How did that get to 64 by 64? What? It's all right. Wait, is that the grid? Someone explain to me what's happening here. Gonna resave that. Okay, much better. I don't know what that was about. We're gonna re-enable our grid. Didn't we set this up? I could have swore we set this up, guys. We did this. I know we did this. That's strange. Okay. Anyways, I apologize. So what we're going to do is create a new layer. And we're going to call this... Actually... Sorry, I'm making all sorts of decisions here that you probably, in real time, it'll be edited in the main one, but right now it's probably confusing. I think I'm going to keep this on the base layer for now. We're going to keep it at the Z order of negative like 100. It's all the way in the back because we're not going to see this once the game starts. So what this will do though, I need people to stop calling me. What this will do though is it'll allow our camera to move within this frame. So now inside of our camera manager, we're always, no condition, we're always going to, and we need to type, what is the extension called again? My brain. Room-based movement. So action, room-based movement. We're going to move and zoom the camera to follow a certain object within that area. So although at the very beginning of the game we center the camera, that's just a focal point for us to make sure that the camera is set properly at the very beginning of the game. And then like we can center it and then reveal the game to make sure the player's like loaded in right before you actually see it begin. It'll make more sense here in the future. So we're going to just keep moving forward. We need to set the trigger object. So basically we want to set the room object to toast, the trigger. I'm sorry, my brain went upside down and sideways. There's a couple of ways that we can do this actually. So I'm going to restart this. So to get the camera zone movement to work properly, you can add the action, go to toast, and then add the move and zoom camera. So I was going to type camera, but CA will bring it up, camera. Move and zoom camera to the room object. Because we already selected this, it looks a little bit differently if we do it this way versus the other way. So this way it guarantees that the toast object is centered on this. We're triggering the player object, in this case toast. We're going to use the base layer camera at a lerp speed of 0.15. So what this means is like a lerp speed of, oops, I messed that up, of 1 would be a complete like screen width over, right? So 1 would be, it will move at a whole screen width distance apart from your player. 0.5 is the half a distance. So you'll have to move all the way to the edge to then move it, or you'll have to move it all 0.5 would be in the middle. Once you move to the middle, then the camera will follow you. But we want the camera to follow the player almost immediately. We're going to keep the zoom values at 0 and 0, and there's no buffer pixels on the outside. And the reason is because all of our levels are on one plane. Now, if we had done this differently and built something that is like a Castlevania or a Metroidvania in general, we would then want to add some buffer room to make sure that the rooms moved appropriately. And adding a little bit of extra buffers will kind of let you see what room is next to you and cool things like that. Sort of a Mega Man style of looking. But for now, we don't need that. And so we're just going to leave it at this complete base section. So we have move the camera. And we can quite literally just check the game to make sure it starts. And now, as we move our camera around, as you can see, it's no longer just on the floor. We center the entire camera on our player object as we move around. So now we can see below the map. And so we'll have to take that in consideration because we get to decide at what distance do we lerp and where do we center the camera exactly. So if you wanted more distance above the player, say that you wanted to see less below the player while you're playing the game, which is a bit more traditional for the genre, then what we want to do is go to the player object. Let's see here. We want to actually move the camera. And how are we going to do this? We're centering the camera on the player, so we'll always get to see underneath it. I think we're just going to have to... If the camera zone comes up, is that going to work? Yeah, it will. I'm confused. I might have made a mistake. It's very interesting to me. Why is that happening? Move the camera to the room object toast at a lerp speed of, let's try 0.5. Maybe I did this wrong. We don't need to zoom. No, that's in the exact same place, guys, right? I feel like that is. And we're not inside of the room trigger. Oh. Oh. Okay. Oh my goodness. Alex is tired. Okay, so let's yeah. So when you add the move and zoom camera feature to the object that triggers in the room, the trigger object is move. All right. What we need to do is move and zoom camera to the room object, which the room object is camera zoom. Okay, so I did that backwards. So the camera, the base object needs to be the camera. Move and zoom the room to the player, and then leave it as I had suggested originally. So that was on me. I was like, that doesn't seem right. So now the camera won't leave wherever that purple is. So if I wanted the camera to go down a little bit farther, we could move this downwards, and I'll show you. So now when we jump, there's a bit more of camera following our player. We see the floor tween away a little bit from the actual player object. And so those values kind of decide where and how we lerp, right? So going back to our camera controller, we can change our lerp. So I'll change this value to like 25 so you can see more efficiently. Like now it's moving downward. So if we wanted the camera to stay a bit higher up, we could go to a half, perhaps. That doesn't actually seem to be making a difference now. So because of the camera's actual depth to the pink part, or the purple part, pink, jeez. So it'll only move the camera within that range, right? So if we move it farther, we'll be able to see further down as we move around the map. So we get to kind of decide how that camera moves. and what we get to see. So if I keep this all the way up, we can see now that we are at the base level of our game. So we're going to do that. We're going to build it all along this line. And if we want to see a little bit more of the ground underneath it, you just move it down one or just stretch it down one. So because it's a standard sprite, we can stretch it as much as we want without distortion. But if it was a like an actual picture of something, it would look awful. So keep it a flat color if that's what you want to do. All right. The next step. The very next step. We are going to build. That's a good question, actually. What do we want to do next? We've got the camera in control. We've got the basic player movements in place. I think that it makes sense for us to trigger. Maybe we want to. I think we'll add blocks. Let's add some blocks. That makes sense. Let's do some blocks. So that UI element, the debugger, we're going to add into the UI just to organize it. So we have UI, object, cameras on the bottom, collisions, blocks. Now we get to add our first object. So we're going to use a sprite. We're going to name this object a block list, rather. We're going to import an image, and we're going to import the blocks. So we're going to go back to our tile set, go to blocks, and we're going to start with the basic block, which is just normal. Okay. So basic block normal, and we're going to call this one default. I always name the first block in the list default. So whatever we want to see all the time. We're going to add a variable, and now this is an instance variable. So an object, for each time we add an object, it has a variable. So each one has its own variable. And so we want to change a variable to isHit. And we're going to put a isHit on a Boolean, and we're going to start it with false. So at the very beginning of our game, when a block is created, it isn't hit. So it means we can hit it once. And then we can kind of base everything else off of that. So let's start working on getting our blocks into place to make sure that we can get that retro Mario collision feel. So to do that, one of the other things that I like to do is go to my player object, and we're going to add a new point on the player. So we're going to go to our toast, we're going to edit points, and we're going to add a new point. Because these are enabled up here, it includes it for everything. So that new point, though, is up here in the top corner. We're going to move it over to the middle of our player at the very top. So 0. Right? So 8.5, because that's true center, 0. Now, oops. I want you to name that head. We'll just call it head for now. So this is whenever the head, that point, touches an object, we want to trigger it. So now that we have a block, right, we can just drag that block into the game. And if you hold control, you'll duplicate it if you control, click, and move. So we can create 3 blocks. Now, each block is an instance, like I said before. So we have the instance of false. The isHit is false. IsHit is false. And if I change this one to true, it wouldn't change it for the other ones because these are instances, right? So all objects that you create in this game have instances, and each instance can have its own logic. So to control like mobs and other things in the game, other creatures and things that move around, these triggers can be used independently to make them have their own game logic. So for now, we're going to play the game, and as we move, we now can hit these cubes, but there's no collision going on because we haven't set anything there. We can now move through them freely. And the isHit feature isn't doing anything. IsHit, there's no actual change going on. So to begin that whole process, we have to start with adding those collisions to the block. So go to let me drink a thing of water here. So go to the behaviors, and we're going to actually add the platform behavior. We're going to turn this off because these you can technically stand on, right? In Mario, you can stand on them. So might as well give them the collision of a platform. And this will make it so that we immediately push ourselves away from it no matter what. But to give it the illusion that it's bouncing, we want to use another feature in Gdevelop called a tween. Now, tweens have to be assigned independently per object. So we're going to add this to the blocks. Now, all the blocks have a tweening capability. And all that means is now we can move them using, programming rather than needing to like apply physics or force or do anything technical. So what this means at current value is that now when we play our game and we jump, we hit our head and we get knocked back downwards. So we can see that our collision box is actually colliding with this block before we technically should even be hitting it. So that means that we need to adjust, like I said before, our player's collisions. And so I'm going to do a unified edit here just to kind of simplify this whole process. So we're going to go to collision masks, and I'm going to bring the entire area in which I can collide with objects down inside of my sprite. It just gives it a little bit more overlapping room with like the edges in my animations to make it feel like the object is actually colliding with something and overlapping in a way that makes sense. So now we're just going to press preview again, go back into the game, and now when we jump, we can actually see our head going through the object into the background a little bit. And that's going to give some of that feel like it's getting hit, it's moving. So the next thing that we need to do is add the tween to what's happening. So when the collision of the block happens, we are going to return some variables. So we need to go back into our game. We're going to create a block manager. So we're going to create a new object. We're going to call this block. I actually prefer this blue for some reason, but we're going to do block manager. And of course, got to create a new external event. So inside of the block manager, we're going to tie it into the game scene, and we're going to check a condition. So we're going to create a new event group, and we're just going to call this one collision with, we'll just do collision, blocks collision. So inside of the blocks collision, we need to check if that global variable if the Boolean variable, sorry, not global, of the block is true. So if the block list, so we go to block list item, and then we go Boolean, and is hit is true, then we can go through all of the sequences, which also means we need if A1 is false. But it automatically is false, so we don't need to check if it is false. Does that make sense? Because we've pre-decided that it is false. So now we just assume that any condition that isn't is hit is true. It's just automatically going to, the requirement is that it is false. So then we can just call a condition. So if the toast, and we're going to do something called a point check. So a collision check. So we're going to go into collision, and we're going to use the collision, the point inside object collision. And what this allows us to do is use that point that we created, and the point is toast, right? Dot, and now we have to use the text feature, or not the text. Oh my goodness, Alex, the XY of a point object, and it's asking for us to also tie in the name of that object, and we named it head. So we're going to tie in the point of the X point location of it and the Y location of head in both variables. And so we're saying that if the head is inside of something, well, we said toast, but we can change that to block list. So if the player's head is inside of a block, we want to do something. So we're only going to trigger this once while true, because we only want this to happen per instance of block when we hit it. Well, when we hit it, what do we want to do? We got to think like an engineer here. So if is hit is true, then we do this programming. But this doesn't have any programming yet. We need to set it to true because it's automatically default, right? To false. So in the action, we go to block list, we check the Boolean, and we're going to change the Boolean variable. If Boolean isn't hit, or is in false state, which we already know, is now going to switch over into true. So do this once while true for each block. When we do that, we can hit it to true, and we can play a sound if we want to add some game juice. So I think that, I mean, we might as well, right? So let me prepare that sound for you, because currently, actually, now that I'm reflecting on it, it's not in the right folder. So let me add a new, so when you guys get this, you'll also have the audio. So we're going to add a new one for audio. And I'm going to give you the sounds for Super Toast World that I've been working on. And we also have a beautiful soundtrack that's been done by a good friend of ours on our Discord server. Wonderful guy. He's changed his name. I was going to give it his old name, Fatal Exit, but I don't remember what his current name is. But I purchased these from him to be made for this very project. So what we're going to do is, if you end up seeing this the Super Toast World format, you're going to see sprites, tile set, now audio. And inside of audio, we're going to create 2 new folders. We're going to create one, or I will create it. You'll have this, and we'll do sound effects, and then we'll do music for the game. So let's go add, and now we'll do music. And so the first sound effects we're going to add is the block sound effect. So I'm going to keep breaking this down for you to make it even easier. Blocks. So inside of the block, we're going to do the bump sound. So we have bump. And we're going to also need sound effects blocks. We're going to do one for coin or pickups. We'll do pickups. Pickups, blocks, pickups, and then tile music or map level music. Level. Let's do levels. So inside of pickup, we're going to add the coin pickup sound. We can go, actually, we need to add another one. We're going to call this player. Player sounds like jump. That probably makes sense, right? Probably want a jump sound. And inside of the levels, we're going to add the win and lose sound, as well as the grasslands world sound set. So now we have the actual ambient noise for the entire map, the win sound effect, and the lose sound effect. So anytime you die. Okay. So now we can click on oops, I misclicked there. My bad. We can now go into our action, and once the block is hit true, because it's triggering one time, we can actually use this to play a sound. So let's upload it. I just want to make sure that I get the sound volume set right, so I don't blow your ears out when we do this. Let me make sure that everything is set properly. Alex, where did you put it? Hello? There it is. All right. Yeah. So now we're going to set the, we're going to actually click on action. We're going to play a sound, and we're going to play it on a channel. So don't just click play a sound. We actually want a little bit more. We want to play a sound on a channel. This allows us to play multiple channels and multiple audio formats at one time without overriding what's currently being played. So we're going to add this to the identifier of channel 1. Channel 1 is going to be where all of our game audio is played, except for the music, which will be channel 0. And so we're going to add the file. And inside now of our tile set, audio, sound effects, we probably don't need music like that now. Dang, I should organize that better. Oh well. We're going to bump the tile. So now we're going to change the volume, though, to settings, dot audio volume. And we're going to leave it at pitch 1. Oh, I got hiccups again. We can just leave it 1 by default. So we can press OK. And now, whenever we hit this block, it's going to play that sound. Okay. Boom. Boom. But every time. So every time we hit it, it's going to make that obnoxious sound for the rest of our lives. Is it possible to... Okay, so Clayton asks a very important question here. Clayton says, since we're on the subject of sound, is it possible to play a sound off of an equation instead of picking the audio file? What? Yes. Okay, no, I understand. Yes. It took me a minute to understand what you were asking, but the answer is yes. So when you randomize an audio, right? So, well, so yeah. So let's say you have a randomization variable, and you're randomizing something. So if you're randomizing an equation, it doesn't matter how you pick it. So we're going to call it random. If you random in range 0 through or 1 through 5, you're only going to get 1, 2, 3, 4, and 5. So all you would do is when you get the input of random or whatever your equation is, if it equals a certain value, play that sound. So it ends up looking like there's a parent structure, there's a child. So of course, randomize is the first one, right? When this happens, randomize, do random action. If random equals 1, play this audio. If random equals 2, play that audio. If random equals 3, play that audio. That's how you do that. I mean, thinned down even more is kind of, I'd have to look at the way you're structuring it, but you can't really thin it down any farther than that. I mean, there's like a small bit you could do by doing the math somewhere else, but you know, you might as well just do it there. I mean, you can have complete control over it. You just got to know what to write, I guess. The circumstances change, right? It's hard to give you a direct answer, but yeah, the answer is yes, to my understanding. Okay, so now that we hit the thing, we got to do the fun part of the block manager. Sorry, I got out of control there. We need to now do just a bunch of block checks. So, what we're going to do first is, if hit is true, we want the first conditions to fire. So if a tween doesn't exist, so we're going to start with saying if a tween exists, well, it doesn't exist. So if a tween doesn't exist, if the tween for the block identified as is hit, right, isn't there, and we're going to do another one, and we haven't defined these yet, but we're going to do return. Okay. So if is hit doesn't exist and return doesn't exist, then we're going to trigger this to happen. So we're going to trigger this once. So trigger once while true. So when these two things aren't happening or don't exist, do this. So we're not going to predefine our tweens. We have to declare them here. So if they don't exist, right? So that way, like if we're going to say is hit is true because we predefined it as false, we don't have to do this. But we can't really predefine a tween necessarily, so we do it this way. So when the action of tween doesn't exist, we're going to create the is hit first. So then we're going to say tween on the Y position. So tween, and we're going to look for tween object, not scale. We're looking for tween to the Y position, so an actual position. So tween to the Y position. We're going to do the identifier is now is hit, and we're going to pass through the block origin, which is that top point, which we're going to need to change. I guess it really doesn't matter, actually. Origin Y. Or did I spell that right? ORIGIN Y. Oh, it's because I am dumb. I'm dumb. I forgot to do something. This is important. 1 second. We need to... Yeah, okay. I am an idiot. Ha 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 ha. Okay, so the thing that I didn't do was go into our game scene, go back to our blocks. I didn't add all of the variables we needed because I wasn't paying attention. So the other thing that we need to add 2 more variables. Another one is a Boolean, and we're going to call this variable used. And this will help us change. If a block is used, we can change it to a different texture, right? If it's used, disable it or turn it black or destroy it or whatever. And in Mario, it like fades out, right? So origin, and we're gonna do origin Y. This is the starting origin point of each block. And then we're going to set it as a number. And currently we're just going to set it to 0. So it's on the Y location of 0, which is technically all the way up here. So we need to make sure that we have a way for us to mark and store where each of these objects are. Their start location, right? So I'm trying to think. This will work. Okay, so what we're going to do is on hit, we're going to tween that object now. So again, go back to here, tween, go to the Y position, and go is hit return 2, and we're going to go to the block origin, right? So block list dot origin Y, and we're going to do -8, so 0, right? It starts at 0, which there's no, it's default, whatever it's going to be. And we're going to -8, which means go upwards at a linear of 0.1 second. And we're not going to delete anything. We're just going to bump it up there. Okay, so if nothing exists, then take its position and bump it up by 8. And then we're going to now start checking for when tweens are done. So now if the tween is hit does exist, so we're going to go over here and we're going to disable, we're going to copy is hit, and we're going to press J on it once we paste it to re-invert it, right? We're going to trigger this once as well. So if it does exist, and in this case, we're going to say has finished playing. So let me get some more water here. So now we declare if the tween exists, and if the tween is finished playing because we just created it here, trigger this one time, trigger the next step. So the next step is to move it back to its Y position. So then we're going to go back here, go back to its origin, and we are going to just set it back to origin. So you're going to go up 8, down, back to 0 over 0.1 seconds. So it's going to happen really fast. And then we're going to check if, and we're going to call this one return. So now we can say if return is finished playing, trigger this one time, and we're going to now do something else. So this one we don't need to, actually, I don't know why I filled that in. We didn't need to do that. We're going to call this one return. My bad. Like, what? Yeah, there we go. Return, you freaking monkey. And then we're going to make sure that we set those, the Boolean values of is hit and used to 2 different values. So we're going to now check and set the is value, the Boolean of is hit to false, because it's no longer hit. We already hit it once, but then we're going to change the is hit to used, and used will become true. So whatever the block is, it's now going to return the used version of that cube. Okay. So then we can, in this section, go one deeper to check if we can now check a condition of if a block is on hit used or not. Because if it is used, then we want to do this. If it's not used, then do something else. So if we can do that here by adding another Boolean subcondition, and we're going to check that condition, and what we're going to do here is create a comment just so it's very clear what's happening. In this, we're going to now say if used is false, check block type and return action. Okay, so now once it is hit in the collision, then we check if it's used as false, generate something for the first time. And then if it is used, do nothing. Just change it to the used function, and it has no more features. So basically, so now inside of here, we're going to copy and paste the is hit of the object to used. So if used of the object is false when we hit an object, then child node, we want to check the animation of the block. If the animation, because we're going to upload all of our blocks now into our animation by name. So if it is the default animation and we hit the block, we want it to do something. We want it to create an object, a coin, and then give it to us effectively. So we haven't added the coin yet, so we're going to add a couple more components to our game. So we're going to go back to our game scene, and now that we have our blocks in place, we can actually hit them now. So let's go do that. Oh, rip. Oh, yeah. Duh. I'm dumb. Okay. So what we need to do at the start of our game is set the current position of all of the objects to their origin location. So right now origin is 0, which is up here. So what we need to do instead, okay, I'm actually going to make it so I can't click on this. So if that annoys you, if you accidentally keep clicking on the zone, you can go down into your instances and click on the camera zone and just click it once to lock it. Click it again so you can't, this little symbol makes it so you don't click on it anymore. You can't click on it and accidentally grab it. So that way you don't get into layering issues and all sorts of other stuff. So anyways, let me fix that now and go back to what I was doing. Because we have no at the beginning of the scene function, which ties all of our blocks to their current like state, they're going to move on us. So let me develop that real fast. And I thought I had pre-built something for this. And I'm just trying to remember how did. So, well, that's okay, so this is the example project, right? So once we get playing in our example project, we're going to be able to do stuff like this. And those blocks need to make sure that they stay in the right place. So give me just a second. Yeah, okay. I'm a goober. Okay, so underneath the, in the very beginning of the game, when we initialize the game, I don't know how I forgot this. At the beginning of, so we can just do beginning, BEG, right? At the beginning of the scene, this happens once. What do we want to do? So we need to use a for each instance of a block. So a lot of people end up using this feature the wrong way. So I want you to look at this. So when we right click on the child and we want to add for each object. Okay. Now the important wording here is click to choose an object. This event will my goodness. Click to choose for which objects this event will be repeated. At the beginning of the scene, each object needs to do something. What object is it? The block. So for each instance of this object, which means each instance is every number of them on the map, for each of them, do this one task. So each individual needs to do one thing. Now, people end up trying to use this for creating finite state machines for their enemies, and they end up messing this part up because this says repeat for each number of instances there are. So, but in this case, we're repeating it for each object, but if you do this the wrong way, you can end up triggering it so that all of them randomize and share the same data. So because we're only changing one element, an instance variable on this object, we can use this properly. So at the beginning of the scene, for each instance of the block that already exists in the game world, no matter what it is, we're going to do an action, and it's very simple. We're going to change a variable, and this is a number variable. The number variable is origin y, and it's simply going to be the block's location, so block list dot y. So what we're doing is we're storing the y location inside of a variable for each of them. So now when I go to the game scene and I click on it, it says the origin is 0. But when we launch the game, we'll be able to see that the origin changes. And we'll see this because the blocks won't move all the way up to the top of the screen. So now we actually have a spot where we can hit our blocks and at least one time, and they return. Okay, so now we have our initial bump script. We can now hit the object, we can hear it, and the objects are in the right spot. So even if I created a new one, it doesn't matter how many of these I create now, that our jump script will always do what it's supposed to do. It'll always, our spawn script. And I recommend at this scale for jumping, you have two blocks apart. So that way your head, you can actually jump, at least for these blocks, right? Because we want to be able to get on top of them. Now, there's some math that we can do to decide how high up we jump, and I'll explain that later when we start fine-tuning the mechanics of our game. But for now, we want to be able to jump on here with relatively no issue. So if you just press space, you won't be able to jump on it. You actually have to hold the button down to be able to get high enough to jump on the platform. Okay. So with that in, we now can work on another collision. And for the collision, it's actually going to be an object. And I want this will be like our collectibles. So we're going to create a new folder, and we're just going to call this pickups. Okay. So the very first pickup that we do in our game is a coin. Pretty much. I mean, that makes sense, right? So that when we hit a block, we can also create a coin. We need to start by adding the coin's animation as well as don't remember. Doesn't matter. Whatever. Can't remember what I was going to say. It's pointless. So we're going to add a sprite. We're going to call this coin. Simple. Import. And inside of our Super Toast World sprites, we have the awesome 6-frame animation. So we're going to also change this to a loop animation and change it to 0.1. And that just makes sure that we have a nice glossy animation for this pickup. We're going to name it because it's the default for coin. Maybe we'll add some more animations later or change the type of coins, maybe change the color or something. More points, I don't know. We're going to hit apply. And now if we add the coins around, we can see them animate in our game. So, oops, doesn't really matter where you start. And move over here, and now we can see that they're all nice and in sync. We can't collect them yet, but there it is. So, in our block manager, I'm going to close down some of our player finite state machine stuff. In our block manager, when we hit a default block, right, we now want to start building up on what happens. So we're going to we're going to create an object. So when we collide, and when the object becomes used, if it is a default block, we're going to create a coin. So we're going to create an object. Object to create is a coin, and we want to put it at an X and Y location. We're actually going to put it at a block point. So we're just going to hit OK, and then we're going to go back into our game and go to our blocks. And inside of our block, we're going to add a new point. So this is where our coin is going to spawn when we hit this block. So what I like to do is build it. So, where is my origin? Okay. So let's see. We're going to put the origin and the, I guess the origin doesn't matter. I'm thinking about it. Leave the origin. We'll just add a new point, and we're going to call this coin. And we're going to add this straight to 8.5. And it'll be 0. So we can move this over as well if you guys really want to. 8.5 and 8.5, just so that the center is true center of the object, an odd division. And look close, hit apply. And now that we have an invisible point that you can't see. Okay. And so now that we have this point, we can type the coin needs to spawn at the block list dot point, like we did before, point X, and the X now is coin. Okay. And we're going to do the same thing for the Y. But now, because of where it's being designed and where it's spawning, we need to make sure that when we spawn our coin, it doesn't spawn inside of that point value. So the best thing for us to do here is to change the math just a little bit to, in the Y position, -2 means +2 pixels in the upward direction, right? And then whenever we create it, we're also going to change that and change the Z order of our coin to equal the block Z order -1. So that looks like block list dot Z order -1. So it'll always be 1 below the block. So the coin isn't created in front of the block, it's created behind it as it gets hit. And this will just kind of create a good effect now that it will generate a coin and it won't make it look ridiculous. So let's get back into our game. And now we're going to hit this and create a coin. Well, that didn't work the way I thought it would for a number of reasons. So this is good because now we see our coins are spawning way over here. What happened? Why did that happen? Right? Well, first of all, we need to make sure that we trigger this once while true. When the animation is default, trigger this once, not 1,000 times, not every frame. Those coins were there's so many coins there you couldn't even tell. There's so many of them. So we got to trigger it once. Don't want to fail on doing that. And then the position of the coin isn't spawning in the right location. What happened? Well, that's pretty straightforward. Whenever a object is created, it uses its origin point. So in this case, because this is a weird sprite, we need to make sure that's actually in the center here. And also we need to set the origin point. So we're going to use the origin point as the base of the coin, like we did with the player. So at the bottom, in the middle. So now when we're going to, basically when it spawns, it's going to move up to and spawn at that location, and it's going to move the whole coin up. So now we're going to hit that, apply. And because we centered that inside of the points list, now when we create it at that location, it'll create it exactly where we want it. Okay. Hey, what's going on, Avecta? I didn't see you in. I was scoping out my actual code. Thanks for joining. How are you? Okay, so now our player is behind the coins, which is fine because we're going to start collecting them here in a moment. And it'll only happen once. So for us to advance in the collecting system of our game, we just need to kind of build a mechanic, an advanced mechanic to control the collection system and getting points and everything else. So we're going to start working on that here just a second as I'm rearranging some stuff around so I can see chat while I'm working now because I accidentally did that. My bad. Blocked you guys out. Rip. All right. Oh, I appreciate it. I appreciate you joining us here, man. All right. And then, of course, to kind of polish up the block, actually, before I continue any farther, we're going to add another animation. And again, for those that are joining us and don't know, all of these will be available at the very first actual video I edit from the series. So you'll be able to download all of these sprites in the future, and it'll look just like this. So if you go into your sprite section, oh, blocks. I was in the wrong area. We're going to go, goodness, Alex. Tile set. We're going to go to our blocks. Inside of our block, we're going to take the used block. Okay. So now that we have the used block, used, we're going to name it used as well. It doesn't have a loop or anything like that. Just add it to the point. Now, inside of our block manager, once we've hit the block, we can now check when used is true. If used is true, we want to pass through a trigger once. So this needs to happen once while triggered. So once this happens, we don't need to check any further of like the block type. So we're actually going to get rid of everything else underneath this guy, and we're going to put it into one simple line. So we're going to take the animation. We're going to change the animation. And I don't change the animation anywhere else, so I don't have anything to copy, so we're going to have to do it manually. We're going to go here to the block list, and we're going to type animation, and we're going to do it by name. So we're going to change it to used. Very simple. So when a block is used, change it to used. And now that's inside of the... See? And so now we can't hit it anymore because we're like small toast. And now it makes sense for what's happening here, right? Now, in other Mario games, you could actually make it so that way the block still bounces, but nothing happens. I think that it's really important that while you're designing, we keep it simple before we polish it up. So what we see right now is a very simple solution for blocks that have already been hit. And there's a nice little sound bit, which you guys actually can't even hear now that I'm thinking about it. Here you go. Let me turn this up for you. There you go. Now you can hear the game. So now we have this nice little sound effect when we hit a block. That might be really loud. I apologize. I'll turn that down a little bit. There we go. So let's see. For coins and block management, I think it's appropriate, even just to keep it in the spirit of organization, right? So we'll just do this one. We'll call it player manager as well, just to keep everything nice and organized. Blocks, debug should be on the bottom. Blocks should come before players. Objects come before blocks. Actually, they don't. Block, object, player, debug, camera. Okay, good. So now, instead of object manager, this is actually the one that we're going to need for like coins and stuff. So we're going to go object manager. We're going to connect it just like we did everything else. Okay. And now that we're inside of the collection manager, we're just going to create a new event group. We're going to call this one coins. And it's really, really straightforward, guys. Like, add a condition when the player is in collision with a coin. So collision, coin. When you're in collision with a coin, trigger this once while true, and play a sound and delete the coin. So play a sound, and we would actually add to our score, play a sound, delete the coin. So we don't have a score yet. So we're going to add that real quick. Might as well. So we're already here. So we have a debug text, right? And now going back into UI debug, we're going to duplicate the debug text, pull it just into UI. We're going to rename it. You could have also just created a new text object if you wanted to. We're going to call this score. Okay. So now, just like we did before, we have our score. We're going to turn off the shadow to make it not blurry and gross. And we're going to add an outline that is black on the white text. No, black text, white outline. We're going to do white text, black outline. And we'll do a thickness of 4. Bring that sucker into here, and we're going to call this one score. So we're going to leave it big and blurry or whatever as it is right now. It doesn't really matter. There we go. And now we're going to see not only the finite state machine, but we're also going to see the score change in real time. So to do that, every time we collect an object, every time we collect something, when we trigger this one time, we're going to change the score. So we need to go back into, we need to make sure that we set the variable for our score. So we have lives and timer in our game data, but we have no score. So we're going to add a new child as a number down here in the game data. I'm going to collapse these so you can see more, or see more efficiently. And we're going to change this to score. And the score is going to start out at 0. Okay. So now, every time we collect a coin, we're going to change the score. So we're going to, we don't need to add it like that, actually. We need to set a score value. So what we need to do is trigger once. We're going to variable. We're going to change a number variable. We're going to change the score. We're going to add, and we'll do, I don't know, 10? 10 for a coin? I don't remember, or 1. Actually, we could just do 1 for a coin. And coin, you get 1 plus 1. I think, though, you know, 10 is a rounded value. It looks nice. I don't know. So we're just going to add to that value. We're going to change the variable. Oh, I did this wrong. Silly. I need to do global variable. My brain shut off there. Same thing, though, but it's an add number variable. That's a structure, array, change, number, variable, global structure. My brain turned off, my guys, my apology. We need to go to score, and then there we need to add 10, okay? So every time we do something here, we're gonna add 10 to our global. Now, because in our debug manager, we can turn our debug manager into a text manager in general. So what we can also do is copy this and change debug to score, okay? And then it's always just, instead of state, it's going to be score. Oh my goodness. And because it's also defined as a, this one we're going to have to use game data dot score. I don't think that's going to work because score is a number value. Oh, it did work. I'll be a monkey's uncle. All right. Dope. I didn't know that was going to work. Why are you so much bigger? Is it the thickness? Is that what happened here? I had a thick boy text. What? Bitch. Let's try this. All right. I don't know what happened there, but we're good now. Oh, I'm such an idiot. You gotta add your text to the same section, guys. Jeez. So when you, Alex, so when you add your score, make sure you add it to the actual place you're supposed to add it to, right? So now, right, when we get a coin, we're getting it every time we touch this thing. Okay, our score's going up. We need to then, of course, delete and destroy the object. So now, once we've collected it, actually, I want to play a sound first. So we're gonna say play, and we're gonna play a sound on a channel. And again, we're gonna always use channel 1, and the volume is always going to be set to the global variable of game settings, audio volume, always. And that way it just constantly plays at whatever the player has it set to. We're going to set this always to channel 1 because, again, that's where all the action happens in our audio format. So now, going to our pickups, we're going to use the coin pickup, leave it as it is, and hit OK. So now we're going to put that first, play the sound, give the score, delete the object. Every time. Delete. Just go to coin, delete the object. So every time now, if you delete the coin before you give yourself the score, it won't give you the score. So now we have it, and when we jump, ba-doom, ba-doom. Look at that. Look at that. Okay. Now we can actually increase this to for each time we encounter a coin, do this, because then if we touch more than one at one time with our body, we collect both of them. And that'll be important later on for polish, but I'm intentionally not doing it now. Growl at me later. Okay, so we have a score, we have a status, we have everything we need to begin our collecting journey. So the next part, and let's see here. What time is it now? How long is the stream? Almost 3 hours. Okay. I think tomorrow, let me get to a spot where we can finish up today. And tomorrow, what we're going to end up doing is defining all of our tile set, making our tile set beautiful, uploading every single piece, and teaching you how to use my tile set for your game, for making your own Super Toast World. And so I think that's what we're going to do there. Let's get a little bit more detail into our game before we do that. I'll be starting the stream at 10 a.m. Pacific Standard Time, potentially 9:30 a.m., but that is unlikely. It depends on a few factors. My plan is by 10 o'clock. My hope is 9:30. So we'll see. But if you join us on Discord, you'll be able to get live notifications for that sort of stuff. for when I go live. I post on Twitter and on Discord. Okay, so one of the other things that I wanted to add to the game before we leave is to start giving it that a little bit more polish, just a little bit, just a small amount, okay? And so before we leave here, I want to leave you off with this little beauty. Hey, listen, I'm not calling it X. We don't zoot, okay? We're not zeeters. We don't zoot, whatever. We tweet. We tweet. Yeah, no, not doing it. Okay, so in the camera, or in the collisions, in the tile set, that's actually not a collision. Where are we going to put this? We need a new section. We're just going to call it Parallax? L-A-L-L? I don't remember. P-A... It's 2 L's. It is 2 L's. Hey, absolutely. Don't stress it, because all these videos are going to be on live and they're available in my live stream section. But I'll also be editing everything out of this before the Gdevelop game jam, so that people have all the information they need to make a really robust platformer in case that happens to be something that happens, or a game that they want to make. So I'm trying to get all this out as soon as I can and get my base series up and running as it should have been. I've been a little distracted recently. Had some real life tragedy happen, so I'm looking forward to getting back into the mix. So thank you guys for joining us back in today. It's really super important to me, and I'm super thankful to see you guys here. And there will be more rigid formatting for live streams in the future. Right now, I can't commit to that. So anyway, so in Parallax, we're going to go down and finally create a, actually, I think this is just a sprite. It's a single sprite, and this is our grasslands, that's fine, just grasslands is fine, actually. So now I just need to equip this into our game. So let's go to our Parallax and make sure that all my parallaxing is set properly. Don't want anything not working right. So we're going to take this one out and move it into our folder. So we're going to go into Parallax. We're going to paste that in here, and I'm going to rename it so it doesn't have .png3. So it's just grasslands, Parallax grasslands. Okay, Alex, stop clicking random buttons, sir. All right. So now that we have the Parallax section, you can upload it, and the default dimensions. I buggered this up. I love it. I love this. This is my favorite part about being a developer and teaching, is that I make mistakes all the time. So go into here, make it a tiled sprite. I'm dumb. And make it 320 by 180, because that's the default tile set size. We're going to call this Grasslands Parallax. And we're going to choose what I just uploaded right there and hit apply. There we go. So now, okay, when I add this parallaxing in, we're going to make this to the Z order of 1. 0, actually. 0. Background should be 0. Now when I scale this, right, it's going to infinitely repeat itself. But because it's a tile, it's a parallax, we can do something even easier with this, and we'll never have to actually move it off of this one point. We're just going to use a scaling factor. We're going to, or not a scaling factor, we're going to use the actual parallax tool to make the parallax work. And I actually want to save the in-depth part of that for another time. So I can deep dive how to do that parallaxing, but for now, for our game example, because it's a tileable sprite, we could potentially just increase this to the size of our level. Because the reality is our game is really going to just look like this, right? We're going to create a platform. That's how platformers are made. It's just going to continuously go, and we're going to have all of our obstacles and things along that route, right? So we can now just hit preview and now land our game in and start our journey, right? So we have our parallax. It's not real parallax, but it does work. This is a good illusion and kind of the way that it would have been done in the old games. But now we're going to modernize that and we're going to make that a whole polished part of our video. So I'm not going to go into that right now, but that is the basics of that. And I think that it'd be pretty cool if we added in maybe world sound. Maybe we add in the audio for the level and is there anything else I want to squeeze into this video? Not yet, I don't think so. So just the audio for now. Yeah. Okay, so we're going to, you can't really add any audio here. That's not how you do it. You have to go into the game. And in the game scene, at the beginning of the game scene, when we first start, I think this is a perfect time for us to start that music. So at the beginning of the game scene, we're going to play music now. So toast. Wait, no. I don't know why I tried to assign that to the player. Don't do that. Play is what we're doing. Play music on channel. Play a music file. Nope. Play music on a channel. We're going to play the Super Toast World soundtrack for the first level, which is an audio and levels. And it is the Super Toast World Grasslands MP3. We're going to play that. And we're going to play that on channel 0 because we want it to be different than the other audio because we don't want it to overlap the audio, if that makes sense. So instead, we're going to set the volume equal to the settings again, settings dot audio. So now, no matter what happens, it'll always stay the same. And it's that simple. And there it is. All right. We've got some life in our game. Feels like a game. So the next thing that I would like to do is flip my character around. I don't like that the character doesn't face the right direction. And I think that's a perfect spot to polish and end on that note. So let's finish our player's movement and let's get this done. So because we added that 3D flip earlier, we can now go into our player's behavior and add some of those advanced mechanics, and we're going to add that 3D flip. So 3D and 3D flip down here on the bottom. 3D flip is just a feature that an extension that we add to our player, and then in our game script, while we're moving, in our actual movement, we can just change the animation. So if the player, for example, is moving, and if the left key is being simulated. So we can now go back into our player finite state machine. And because all of this is always running, we don't need to check some of what we want to do in every state. We can just do it in the player finite state machine at large. And so if the left key is being pressed or moved, for now, I do want to actually restrict it to... No, I think it's fine if we put it out here. We may have to adjust this later on, but I think it would be fine if we were to create a new event and just say animation controller, right? And we're underneath the initialize the player. What are you saying? No, just watch. So if we use the animation controller and we put it underneath the player initialize and we remove this part, this doesn't matter. What we want is two different actions. If the player, so if at any point in time the toast, if left key, so we can actually check if a key has been pressed. So if the player has had the left key simulated, let's go key. No. In here. Key. Pressed. Oh, no. Come on, brain. Function with me, please. If the condition needs to be player. So let's toast. Control pressed or simulated. If the left key is control pressed or simulated, flip to the left. So we're checking at any point in time in any of these scripts, if we're going left, do something. What are we going to do? We're going to flip. We're going to flip it. So we're just going to tell our player to 3D, flip the object, and we're actually going to go flip to a side. Reverse side, yes, over 150 milliseconds. And again, we're going to copy this, paste it, change this to right, and then we're going to say no. Don't reverse the flip onto the non-reverse side. And it looks a little confusing, but watch this. Now, when we flip around, it just works. There we go. Left, or right in this case, left, right, and everything works as we'd expect it to. All right, guys. Thank you so much for dropping into this video, and I hope you learned something this time. Tomorrow I'll be going live again to polish this up and continue the series. We're going to be covering everything you need to know to make a Super Mario World platformer, including overworld, transitions, carrying objects and overworld things with you between levels, and all of that good stuff, including the fine mechanics to make the game. So thank you for watching this live stream, and in the future, look forward to seeing this edited into a singular series format. Remember, everyone, happy game making, and I look forward to seeing you in the next video.